This is the screencast for section 2.2, example 4. We're going to look at vertical asymptotes. You saw a vertical asymptote in example 1 with 1 over x. It had that vertical asymptote at x equals 0. In calculus, we define a vertical asymptote as a line x equals a when the limit as x approaches that a value from the right is either positive or negative infinity, or when the limit as x approaches a from the left is either positive or negative infinity. Either one or both. So for example, find the vertical asymptotes of f of x equals 1 over x squared. Well, I already know what that graph looks like. I definitely know that x equals 0 is going to be a vertical asymptote because the 0 makes the denominator 0 only. I'm going to draw a little sketch of that graph. It's just like 1 over x except it's squared, so everything is positive. Now we have to describe the behavior to the left and right of each vertical asymptote. So the limit as x approaches 0, the vertical asymptote, from the right of f of x is infinity. And actually the same thing goes for the limit as x approaches 0 from the left of f of x, also going to approach positive infinity, which you know from last section does mean it has a two-sided limit as well. You could say the limit as x approaches 0 in general of f of x equals infinity. Now for number 27, find the vertical asymptotes. Well, positive 2 and negative 2 both make the denominator 0. So x equals 2 and x equals negative 2 are the vertical asymptotes. And I know that you are probably awesome and already know what this graph looks like, but let's pretend you're not awesome just for a second, okay? It's just for pretend. Describe the behavior of f of x to the left and right of each vertical asymptote is tricky if you don't know what the graph looks like. But we have a way to test this out. You have to dig back into your pre-calc brain, pre-calc section of your brain. We're going to do a number line with f of x on it, and we're going to put down our critical values negative 2 and 2, and we're going to test. If I plug in a number way left of negative 2, so like negative 1,000, I'm going to get a positive value output. If I plug in a number between negative 2 and 2, easiest one is 0, I'm going to get a negative value. If I plug in something really, really large, like positive 1,000, 1 over positive 1,000 squared minus 4 is going to be positive. So I can tell you that my function is going to go positive here, it's going to be negative here, and then positive here. So I kind of have a mock of what the graph is going to look like. So without even knowing what the graph looks like, I can tell you that on each side of these asymptotes, I can describe the end behaviors. The limit as x approaches negative 2 from the left is going to approach positive infinity, but from the right is going to approach negative infinity. Then over here at positive 2, the limit as x approaches positive 2 from the left would approach negative infinity, but from the right would approach positive infinity. And just to make sure, I'm going to put the graph of the function right here. Sure enough, see how the whole graph is positive here, stays negative, and then goes back to positive between the vertical asymptotes? So my end behaviors are correct. As we approach negative 2 from the left, we go to positive infinity. From the right, we go down to negative infinity. Approaching positive 2 from the left, we go down to negative infinity, but positive 2 from the right, up to positive infinity.